In this video I'm going to be going over the problems that have been changed on the review. Again, we did this to try to make things a little bit easier. It was previously pretty long, and anyway, some of the numbers were kind of crazy. So anyway, let's go ahead and get started. On number 3, notice we don't have a minus x squared in front here. In this problem, let's see, first of all, let's identify a and b here, because we're going to be using the vertex formula. Remember, that's x equals negative b over 2a. We're graphing a parabola. Quadratic functions, when we graph them, we get a parabola. It's U-shaped. And the most important point is the vertex. Now, we learned a technique where we could actually write this function in vertex form using a process called completing the square. And you could do that here. But we're going to go ahead and use the vertex formula. So negative b, that's going to be negative 6 over 2 times a, which is 1. So we're going to get 6 over 2, which is 3. So remember, this is just the x value of the vertex. To find the y value of that point, we need to plug 3 into the function. So 3 squared, that's 9. Minus 6 times 3, or minus 18, plus 5. We're going to get negative 9 and 5, which adds to negative 4. So our vertex is the point 3, negative 4. Always recommend that you plot that point. And actually, let me just write down the axis of symmetry here. That would be x equals 3. It's always x equal whatever the x value of the vertex is, in this case 3, because the axis of symmetry is the vertical line that goes through that point. So let's go ahead and put that on the graph. And we know that this graph is going to open up because we have a 1x squared. A is 1. And so we kind of already have a feel for the graph. It's going to look something like this here. We just need to find the details. We need a few points. So the y-intercept is really easy to find when we're in this form, because if you plug in 0 for x, which is what we do to find y-intercept, we're going to get 5, because the 0 squared and minus 6, 0, that's all 0, and we're just left with the 5. So 0, 5 is our y-intercept. To find the x-intercepts, we want to let y be 0. Remember, f of x is just another name for y. And so now we need to solve for x. So we need two numbers that multiply to 5 and add to negative 6. We're just using the AC method here. So you should find that negative 1 and negative 5 are the numbers that work. And since this is a 1x squared, we can plug those in. And when we solve, we get 1 and 5. So we chose y to be 0, and we got 2 values. So there's going to be 2 x-intercepts. And again, notice both of them have y values of 0. So let's go ahead and put these points that we found, the y-intercept and the x-intercepts, on the graph. Notice I also have the point, what is that, 6, 5. Since 0, 5 is on the graph, you can go 3 away on the other side and you'll find that other point. And other than that, I just put in the x-intercepts. And you can see the symmetry with the x-intercepts as well. So now we need to answer some questions about our graph. Our domain is all real numbers because there is no left or rightmost point. Now for the range, we want to go from the lowest to the highest point. And at our lowest point, the y value is negative 4. And it goes up forever, so there is no highest point, so we would say to infinity. So notice we're going to have a minimum here at our vertex. And that would be the y value there, which is negative 4. So where is the function increasing? That would be right here. So we're going to say, let's see, when x is equal to 3, that's where it changes, right at the vertex, right? So when x goes from 3 to infinity, so basically over here, as x keeps going this way, the function's increasing. And similarly, it's decreasing on the other side, basically from negative infinity until we get to 3. All right, so that does it for number 3. Let's move on. Alright, so on number 9, it says for each function find the x-intercepts and behavior at each x-intercept, or at each intercept. So on letter A here, you can see that x is going to be 2 and 3. Those are our zeros, and those also tell us where our x-intercepts are going to be. So I'm going to go ahead and make a table here with x-intercepts, multiplicity, and behavior to help us do this problem. And in fact, I'll go ahead and put it in for all 3 of these, or the other 3 as well. So on the first one, our x-intercept that goes with the 2 would be 2, 0. And our multiplicity, notice the exponent there is 1 on that factor, x minus 2. And that's the one that corresponds to the point 2, 0. And so we have a multiplicity of 1. And the behavior, we always cross when we have an odd multiplicity. So anytime we have an odd number of factors, in this case we have one factor of x minus 2, we're going to cross, and anytime we have an even number of factors, like with the x minus 3, we're going to bounce. So at 3, 0, our multiplicity is 2 because of that exponent there, and we're going to bounce at that x-intercept. Alright, if you look at letter B, we're going to have to do some factoring first, and I think the first thing I want to do is change the order and put our leading term first. And now, since we have a negative in the front, we're going to factor out a negative x squared, in fact. That is the smallest power of x that the two terms have in common. So let's see, it'll be x squared, negative x squared times x squared is going to give us the minus x to the 4th. And then be careful, this should be a minus 3. Notice negative 3 times negative x squared will give you a positive 3x squared, which is what we need. Now, to find, I have actually 2 more intercepts here. When you look at that x squared minus 3, if I set that equal to 0, I can see what my other 2 zeros are. And so we'll add 3 to both sides and take the square root of both sides. You get x is equal to plus or minus the square root of 3. So we have 2 x-intercepts here, the square root of x. I'm sorry, we have 2 zeros here, square root of 3 and negative square root of 3. We also have x as a factor, x squared, so x equals 0. Oh, I'm sorry, I wanted to show you you could actually write the polynomial by using x minus square root of 3 and x plus square root of 3 as factors. And so finally, our zeros, notice x squared is a 0, so our x is a 0 there, so 0 is a 0. So notice we have 3 zeros here, and we'll have 3 corresponding x-intercepts. So 0, 0. Let's see, notice that exponent there is 2, and so the multiplicity is 2, which means we're going to bounce at 0, 0. And then for square root of 3, 0, notice that's to the first power. Both of these are to the first power. So the multiplicity is 1, and the behavior, we're going to cross at that x-intercept. And similarly with the minus square root of 3, 0, same multiplicity, and it's also going to cross. Alright, let's move on to letter C here. So first of all, you can see that x to the 4th is the GCF for these two terms. So notice x to the 4th times x squared will give you the x to the 6th. And we need to multiply by a minus 9. And that'll get us the other term. Remember, you can always distribute here to go backwards and double check yourself. Now on the right, you can see x squared minus 9, that's a difference of squares. And so let's go ahead and factor that too. And so you can see we're going to have 3 zeros, 0, 3, and negative 3. And so our first x-intercept would be at 0, 0, and because of that exponent, this 4 here, we're going to have a multiplicity of 4, which means we're going to bounce at that intercept. Now notice the other 2 are to the first power, and so at 3, 0, the multiplicity is 1, so we're going to cross, and the same thing's true at negative 3, 0. Last one, notice on letter D we've got 4 terms, and definitely looks like we could factor this by grouping. When we're working with polynomials, we always want to break them down into their factors by factoring using our old techniques, if at all possible. We don't want to have to do the rational zeros test and look for that first zero unless we really have to. So notice here we can factor by grouping. Let's group our first two terms. We can factor out an x squared, and it'll be times x minus 5. So when we factor the other two terms, we're expecting to get a factor of x minus 5. And you can see to get that minus 4x, we need to multiply by negative 4. And notice negative 4 times negative 5 does give you the 20. And so now we have a common factor of x minus 5. And you can see when we cross those out, what's left is x squared minus 4. Again, we have a difference of squares. We end up with x minus 5 times x minus 2 times x plus 2. And notice these are all to the first power. Those are our zeros, 5, 2, and negative 2. And notice everything is got an exponent of 1, so multiplicity on all these is going to be 1. So at 5, 0, our multiplicity is 1, and so we're going to cross. Same thing for the other two. Alright, so now let's talk about end behavior. So with end behavior, we do what's called the leading coefficient test. Particularly for problems like B through D, have to handle things a little bit differently with a problem like letter A. So first of all, let's look there, and you can see the degree. Remember, we when a polynomial is in factored form, we add the exponents of the factors, all algebraic factors. So only factors that have an algebraic symbol like x in it. So the degree here is 3, and notice we're negative out front. So this is a case where we're odd. It's an odd function, and the coefficient of the leading, well, the coefficient out front in this case is negative. And so this is like y equals x cubed, except for it's because of that negative, it's reversed. I call it the reverse John Travolta graph. Let me go ahead and put graphs for each of these. So it's going to rise on the left and fall on the right. That would be the opposite of y equals x cubed. Alright, so let's look at B. So at B, you can see that our degree is 4. And be careful here, we have a minus in front of that leading term, even though it's actually the second term, the way it was originally written. So we are even, and we do have a negative coefficient out front, or in front of our leading term. And so this one's going to act like y equals x squared, except for we have a negative, so it'd really be like minus x squared. We know with even functions, they either open up on both ends or down. Because of the negative, we're going to open down on each end. Or we say the graph falls on each end. Alright, and then letter C. Notice 6 is going to be our degree here. And we do have a positive 1 out there, so we are positive. So we're even and positive, which means we're going to be kind of like B, but this time we're up on both sides. So we're going to rise on each end. And then the last one, D. Notice our degree here is 3, and we're positive. And so that would be odd and positive. And so that is the John Travolta. Or again, it acts like y equals x cubed. It's going to fall on the left and rise on the right. And that does it for number 10. Alright, let's look at number 12. So it says, write a possible equation for the function with the given zeros and multiplicities. Assume multiplicity is 1 if not stated. So for 12a, let's see, if negative 2 is a 0, then first of all, let's write this as f of x equals, we're creating a function. If negative 2 is a 0, then we know x plus 2 is a factor. If 0 is a 0, we know x is a factor. And if 5 is a 0, we know x minus 5 is a factor. In fact, there's 2 here since 5 has a multiplicity of 2. So this is going to be a lot of work to multiply. It's just algebra, but it is a little time consuming here. I'm going to go ahead and multiply these two factors first. So let me do that off to the right. So all we're doing here is foiling first, outer, inner, last. And when you do that, you should end up with x squared minus 10x plus 25. So let's rewrite the function and we'll put that in for those two factors. So now we're going to multiply the x plus 2 times that trinomial. So I'll do that over here. So I'll want to multiply or distribute the x times each of those three terms. And we're going to get x cubed. X times a minus 10x is a minus 10x squared. X times 25 is 25x. And then 2 times x squared is 2x. Well, we'll do the same thing with the 2 now. We'll distribute times each of the three terms. So we'll get a 2x squared, a minus 20x, 2 times negative 10x, and 2 times 25, that's going to be plus 50. So let's go ahead and combine our like terms. X cubed is the only cubed term. Negative 10 and 2, that's negative 8x squared, plus 5x, plus 50. Alright, so don't forget, we still have that x out in the very front. So let's multiply everything by x, which really just increases the power of x for each of those, and then the 50 has an x now. And so our final answer here is f of x equals x to the 4th minus 8x cubed plus 5x squared plus 50x. Let's go ahead and look at 13 now. I'll go ahead and do a and b. B and c are unchanged, so I'm not going to worry about those. So on 13a, let's go ahead and set this up. So what we put underneath this symbol here is called the dividend, and we're dividing it by the divisor, 5x minus 3. And what we ask ourselves is, well, we really just look at the leading terms, the 5x and the 30x squared, and we want to ask ourselves, what times 5x will give us 30x squared? Well, that would be 6x. And so now we'll multiply 6x times the binomial 5x minus 3, our divisor. So we're going to get 6x times 5x is 30x squared, and 6x times a minus 3 is a minus 18x. Now we have to remember we're subtracting this from what's above. And so 30x squared minus 30x squared gives you 0, and you should always get 0 in that first term. And then negative 3x minus a negative 18x becomes plus 18x, and so we're going to get 15x there. And then we want to bring down the plus 8. So this whole process is very similar to how we divide just regular numbers in arithmetic, but it is obviously a little different. Now we're looking at the 5x and the 15x and asking ourselves what times 5x gives us 15x, and that would be 3. So 3 times 5x is 15x, and 3 times negative 3 is negative 9. Again, we're going to subtract. 15x minus 15x is 0, and 8 minus negative 9, that's going to be plus 9, and we get 17. So our final answer is going to be 6x plus 3, which is our quotient, or the answer to the problem we just did, plus our remainder over the divisor. Alright, on letter B, notice we're dividing by a quadratic function, x squared, or expression, x squared plus 2. So notice we need to put a 0x in the middle there. We don't have an x term. We need a placeholder for it. So let's go ahead and set it up kind of like we did on the last one. Well, just like we did on the last one. Just don't forget about that 0x. And so now we have to ask ourselves what times x is x cubed, and that would be x. And let's multiply x times each of the terms. We get x cubed plus 0x squared, which is really just 0, and then plus 2x, and don't forget we have to subtract that. X cubed minus x cubed is 0. 4x squared minus 0x squared, we're just going to get 4x squared. And 8x minus 2x is going to be 6x. So just like before, we'll bring down our 3. Notice we need 3 terms because our divisor has 3 terms. And so now we're looking at the 4x squared and the x squared and asking ourselves what times x squared gives us 4x squared, and that would be a plus 4. So let's multiply each term by 4. We get 4x squared plus 0x plus 8. And we're going to subtract that from what's above. 4x squared minus 4x squared is 0. 6x minus 0x is 6x. And 3 minus 8, that's going to give us negative 5. Now, we don't have a number here like we did on part A, but we're done because if you look at the degree of this term that we got here, it's got a degree of 1. And our divisor has a degree of 2. And so as long as if this degree is less than that of the divisor, we're done. And so we're ready to write our answer. It's going to be x plus 4 plus 6x minus 5, which is our remainder, over our divisor x squared plus 2. And I'm going to stop the video here.